Start over. My name's Fred Niehaus. I'm from Akron, Ohio. We're the guys that design Wi-Fi stuff, right? So we're excited about Wi-Fi 6. It's complementary to 5G. You know, in fact, it's the same darn stuff, really. If you look at it, you know, it's kind of broken into two things. So you've got 5G being the carrier-based stuff, and then you've got, you know, Wi-Fi 6 being the enterprise-owned kind of thing, right? So they're parallel things. They're very similar in nature. The cool thing, though, is that Wi-Fi 6 has got a little bit more traction. Okay, we're getting there first, right? And that's an important thing, you know, because Wi-Fi 6 is coming. We're excited about it. I got a couple quick slides. Where the hell did all this Wi-Fi come from? Well, you know, Wi-Fi came from that. Years and years ago, you had a retail inventory, and you had to take the barcode and go, you know, and then somebody got mad and said, well, can't I just use a gun and go bang? And we did a gun, married it to a walkie-talkie, 460 megahertz. Hello, Kurtz Rent-A-Car. Hello, where Walmart said, can you make our POS wireless? We're like, point of sale terminal. Okay, we can do that. We'll take a PC and we'll make a 2-part card, jam it in there. And then we went to a 1-part card. Then we went to 2.4, went to 5 gig, all that nonsense. After all that, here's where we're at, right? Started out with 1 antenna, then it started out with 2 antennas. If you had problems on this one, switch to that. Then it was like 2 antennas per band. We'll introduce 5 gig. Then all of a sudden it's like, throw radios on every damn antenna. So we did that, right? After we did that, we started doing spatial streams, multi-streams. You know, in comes that, comes complex modulation. So everything comes out is all about efficiency. Let me get on the air and get my crap done and get gone as quickly as possible. So modulation gains. 64 QAM, 256. Now we're at 1024 QAM with Wi-Fi 6. That's new, okay? OFDM is a new concept too. Basically with OFDM is you have all these subcarriers, and I put one person's data on one subcarrier, the other subcarrier. With OFDMA, which is new in Wi-Fi 6, I create a whole bunch more subcarriers. I can put multiple people on each subcarrier, take away on that's latency. Instead of calling your Lyft or Uber and realizing I got 5 people in no room, you know, this thing's like a train. You know, pulls in, all the doors open, everybody gets in, and off it goes. It's about making the latency go away, you know, making things better. So we've got this timeline. You know, we've been doing this stuff forever. You know, starts with the B radios in '97. I was doing it in about '91 or so. As soon as we broke the 10 meg Ethernet barrier and went to 11 meg.11b, we got Microsoft's attention, then we got Cisco's attention. Then next thing you know, they bought me, you know. I'm like, I didn't agree to be an internet plumber, and here I am doing Wi-Fi with Cisco. So from there, we added cool things, clean air. We put in, you know, hyperlocation, you know, arrays where I can find you anywhere, right? And then guy sits a couple cubes over from me, invented multi-gig Ethernet, Clark Hardy and, you know, Peter Jones, other guys like that. So we've been doing a lot of innovation all the time. So now we hit Wi-Fi 6. So what do we care about this? Well, I don't want to call it Wi-Fi 6. You know, there's a guy from Syracuse University said the same darn thing. I refuse to call this Wi-Fi 6. Well, you know, Wi-Fi 6 brings you all these things. I said more complex modulation, more radios, 8x8, brings you 3 to 4 times throughput. I told you it reduces latency, and there's some things to give you power, right? But why am I calling it Wi-Fi 6 when it's 802.11ax? Well, let's address that. So there's 2 people on Earth, right? You got the IEEE who lay down standards, okay? If I'm IEEE and we're going to make a standard, Cisco is a standards-based company, right? When you do something like PoE, Power over Ethernet, there was no standard, so we do our own. Then the standards come along, and if you don't have anything to market right now, you're kicking sand in that fire going, oh, we've got to change this. And, you know, and you guys all fight and everything else. So we just come out right now with pre-standard things. And then as it gets evolution, we weave it into standards-based things. Well, why am I telling you all that? Well, because they exist there. Then there's a little company called Wi-Fi Alliance, okay? I was part of that when that first started. It was called WECA, Wireless Ethernet Compatibility Alliance. WECA was also a church in Canada, West Edmonton Christian Association. Phil Bellinger come along one day and says, we can't be the Holy Church of Wireless. Let's turn around and call this Wi-Fi. I'm like, hi-fi, high fidelity, Wi-Fi. That's a dumb name. I collect Martin guitars, play you a tune, it's got fidelity. There's no fidelity in this, it's bits and bytes. I like the name. So we helped found that and create that. Now they've become a marketing organization, right? So if 5G is important, then Wi-Fi 6 is one number higher. It ought to be even more important, right? Thank you, Wi-Fi Alliance, right? And this is a good thing. I'm not slamming them. Anyway, they went and turned around and reinvented history. They said, well, let's call, AC, which is 2013, Wi-Fi 5, and 4, and 3, and 2, and 1. I don't know what they called it back when I was playing with it, but anyway, the takeaway there is two groups. The Wi-Fi Alliance certifies interoperability. What works, what don't work. The IEEE does standards, and that's kind of important. And the ratifications on those are down here, right? So Q3 2020 on IEEE and Q3 of this year on WFA. Anyway, if you look at what does the Wi-Fi Alliance certify, because they're the ones certifying interoperability and they're the one calling it Wi-Fi 6. They've decided that OFDMA, which is, as I was mentioning before, a way to reduce latency in things, the spec says that's optional. You can do it or not do it, whether you want to do it in the uplink or downlink. So some chipset vendors have decided they can do OFDMA in the downlink, but not in the uplink from the client up, okay? The Wi-Fi Alliance has decided I'm going to certify inhale and exhale. I want uplink, downlink. I want both, right? So there's some APs out there that can only do OFDMA in the downlink. I've got a bunch of new APs we'll talk about in a minute. One of them is an 8x8. 8x8 was fairly early to market, and my 8x8 can't do OFDMA in the uplink. That means the WFA will not certify it. So you're going to hear this buzzwords, what the hell they call it, certification and compatibility or something. You're going to hear them say, oh, I'm AX compatible, but that doesn't mean you're Wi-Fi 6 certifiable. It doesn't mean you're certified to work, and they've passed all the interoperability, things like that. It's not a huge deal, but it's something that you ought to think about, because right now we've got 3 APs. I'll talk about them. All of them do OFDMA in the up and down link, with the exception of our 8x8 9117. I'll touch on that in just a little bit. So what's the difference between Wi-Fi 5 and Wi-Fi 6? Well, if you look, Wi-Fi 5 is all about throughput, very high throughput. Get as much data out as possible, okay? Problem is most people's data rates are like 320 bytes. I got little packets. Telling me I can move a whole lot of data doesn't help me if the latency's there. Every once in a while somebody will come up, there's a children's hospital, I think down there or Cincinnati somewhere. Hey Fred, when I turn off my Wi-Fi, it seems like my connection's faster. Well, hell yeah, because back then, the carriers buy these frequencies for millions of dollars, and they had OFDMA. You put OFDMA and low latency in there, and things move along faster, right? So what I'm saying is 5G and Wi-Fi 6 now they both do OFDMA. They both do things for power. They all are very identical things. But the thing about Wi-Fi 5 or 11AC is the fact that it was limited in multi-user MIMO. Multi-user MIMO is I'm an AP and I'm going to talk to users at the same time, right? For me to talk to users at the same time, I've got to do beamforming and I got to do anti-beamforming. I got to go, I'm going to take a person here, way over there in the room, put them together. Because if I'm trying to do 3 people in a row beamforming, I can't, because you all hear the same thing, right? So multi-user MIMO is a big deal because it can quickly speed up and help with latency, but only Wave 2 clients do that. Now with AX, it's table stakes. You got to do it as an AX client, right? So that's good. So, the small latency issues, people in IoT, hey, you've done nothing for me in IoT, and 2.4 people are like, well, God, when you did Wi-Fi 5, you put no enhancements to 2.4 gigs. So now there's something called BSS coloring. BSS coloring is a fancy way of saying, I have a cell size as big as this table in front of me here, right? I have a cell size. If I've got limited channels, 1, 6, and 11, if you got a cell on one and you got a cell on one, the worst thing that happens is the client in the middle's got full power. He's screaming out who he is because he's got a poor antenna anyway, and he causes contention with all these cells. Wi-Fi 6 says, put a color on that thing. You're the blue cell and you're the red cell. And then you tell the client, learn about the cells, there's a 6-bit preamble or whatever, learn about the cells, and if I'm connected to you, shut the hell up. Do not run full power. Crank her down and I'll let you talk. I'll give you the benefit, even with all the collisions, I'll let you talk anyway if you lower that power, right? So what does that do? That gives me more efficient use of the spectrum reuse. It makes that 1, 6, and 11 a little bit less painful. You know, it's a cool thing. So that was added. You know, a lot of little things, you know, parallel processing, but mostly the biggest thing is this OFDM and battery life, things like that. There's a whole tick list here of stuff it does. You know, improvements in packet latency, this channel reuse I just described, parallel transmissions, faster modulation. That 1024 QAM is basically if you only have one radio in your device, and you can't do multi-streams because you only got one radio, you're limited to what you can do by either bonding the channel, making it wider, and there's downsides to that. Every time you bond a channel, you lose lower power, about 3 dB every time you decide to take a chunk out of it. Or you can do more complex modulation. Using 1024 QAM, a typical Wi-Fi signal will get a 30% bump in throughput. That's a cool thing, right? So that's kind of the takeaway there. If you look, I've got 3 APs here, and I'll show them in a minute, but 2 of them are standards-based. We just build it, you know, very similar to whatever the standards are. Then you got to come out with something that Cisco can do that nobody else can do, right? So we've done that kind of stuff with APs, and we call them best-in-class APs. So best-in-class AP is something that had client link, which was transmit beamforming before there was any kind of beamforming in the standards, right? So if you take a 4800 AP and you got legacy clients, that thing will beamform, you know, to the pre-standard, all that. If you go to a new Wi-Fi 6 AP, I've deprecated client link. I want to get you away from those old clients, and I want you to get to new Wi-Fi 6 clients, because you got to get about 30% of that network to Wi-Fi 6 before you see a difference. You know, so but client link was a big deal. Spectrum intelligence, clean air, full spectrum, that's a big deal too. Dual coverage, both these things are in the new AX APs. Hyperlocation, precise location, that'll be in some other AP down the road, not today for Wi-Fi 6. And then a new Cisco RF ASIC, and we're going to touch on that if we have time here. So let's look at the APs. So the first 2 are standards-based APs. If you look at the Cisco product line, which I'll kick that over in a minute, is, you know, this is probably our lower early tier APs, you know, like their 1830, 1850 series APs. And then the Catalyst 9120, that's closer to the 2800 series, which is not our very, very best in class, but up there. It's up there because it's got a lot of significant Cisco IP and Cisco cool things, right? But notice there's a name, New Catalyst. You know, I've been doing Aeronet for a million years, and it seems like, and I'm quite proud of Aeronet, and I don't, you know, I'm like, what are you changing it to Catalyst for? That's the first thing I start scrubbing. You know, we change it. Somebody said, you know, Cisco's best product line is Catalyst. You should be happy we're renaming this. And by the way, we're changing some of the designs on these things. So anyway, this is the lineup, but look at the PoE, 15.4, 30 watts. You had a kind of a split kind of middle thing. What they decided to do with the new Catalyst APs is they decided they would redesign it and make it a smaller, lower profile AP. And the first thing, you know, they had a problem with the 4800 with all that aluminum, and I'm like, I'm quite proud of that aluminum. That aluminum makes that thing work in a hot molten tire, you know, steel plant, tire plant, makes it work in a cold Kroger freezer. You're not doing that to my AP, because this is not a sealing AP that's only used there, and if it fails, if you put this in Indiana and the Goodyear tire plant's running the robots around and it fails and it's 35-foot ceiling, and it fails, you don't want me to say, well, let me give you another one and a pair of socks and jacket that's got a cool logo and whatever the hell. No, you know, I want this thing to work, right? So if I've got to jettison that aluminum, that means I got to jettison something out of here, right? Because it's making heat and I got a lot of stuff. I got rid of the local power supply. There's no local DC anymore in these APs. There's also no extra Ethernet port. Those are all kinds of things that pooch out, take power. So we jettisoned that so we could get to the small size that Pininfarina wanted. Who the hell's Pininfarina? Well, I'm from Ohio. You know, I sit in my backyard and play guitar, and I don't know anything about Pininfarina. Well, dude, they're the ones that designed the Alfa Romero. And I'm like, used to be a cop. I got a couple of the stolen ones once. But anyway, you know, long story short, they helped us redesign it, and every one of these APs can run in some function at 15.4 watts. Every one. So if you've got, you know, you can see you can cut it back. You know, sometimes you have to get rid of the USB port, but I've got them so that they'll run on all of that stuff. And I've got them smaller, right? 30%, 38% lighter, 30% lower volume size. You know, everything is really small. If you look at like the 9120, I'm going to touch a little bit about the first two, the two that I showed you. I've got, you know, there's a slight difference between the 8x8 and the 4x4. It's a little bit thicker. We decided we're not going to make it any bigger, but I can go thicker. And the argument there is if I put it on a ceiling, I can get a flush bracket from a third-party company. You know, there's a lot of third-party companies like Oberon that'll make you a bracket that'll go in there, Exceltex. Hell, even Exceltex can skin one up, make it look any way you want it to look. And I thought that was kind of cool, you know. So if you've got a plant or a wall or something you want to blend it in, we've got, you know, they've got the ability to do that kind of thing, right? But the 9120 is our new one, okay? That's the one that's got Cisco IP in it. So if you take a look, this is what it looks like. It's kind of going to be hard on a camera to do that, so I got another picture. But you know, it's got a lot in it. And there's a cool chip called an RF ASIC, and I'll talk about that in a bit. But if you want to look at the antenna system on this thing, it's pretty amazing. The antenna system has 4 dual band antennas that do typical dual band, 2.4 or 5 gig, right? If you choose that you want to do dual 5, which is a big deal, you have to create 2 5 gig, I can have an AP that does 8x8, or I can have a 9120 split off into 2 different channels and do 4x4 both. So basically I'm doing, in a sense, 8x8, but I'm doing it on 2 different channels, so all of a sudden I'm lowering my channel utilization per channel, and I'm doing it in a more conventional way. Also, these antennas here, when you do a dual 5, they kick on and they create a microcell and then a macro cell. And you know, and if you look at what that looks like, it's kind of something like this. So if I'm on one channel and I got clients close in, got clients far out, the ones close in connect at a very, very fast speed. The ones, you know, the ones farther out going, my name is Fred. And the ones up closer, shut the hell up, Fred, get the data out, you know. So if you could take it off of there and split it and go, look, I'm going to create 2 cells, a microcell and bring them in close at their fast speed, macro cell, you know, farther away, let them connect at their slower speeds. I went from a channel utilization of 60% on one channel to 2 channels at 20 and 24% utilization. Well, what's the net takeaway? The net takeaway is the customer gets less retries, the customer gets faster experience, and that's all before you add OFDM and the latency and improvements and everything of Wi-Fi 6. So this is a very cool thing. It was in the 3800, it was in 4800, and we've pushed it now into the 9120. I don't know that there's anybody else right now that has that ability. They may, but they don't do it as good as I do it. Anyway, let's take a look at this. So this is the external version of the unit. It's got 4 RPTNCs, so out of the gate, if you just put your 4 antennas on it, kind of like this one here, put your 4 antennas on it, comes up 2.4 and 5 gig. But I want dual 5. Okay, plug the DART connector in. A DART's digital analog radio termination connector. You shove it in there. I got another 4 RPTNCs, and I can now put the antennas 2 places. I can create a 5 gig microcell, a macro cell, a directional cell. I mean, I've got all this antenna stuff. I'm up 35 feet in the ceiling, and I want to point down. I can point down this aisle with one radio and that aisle down with the other radio. So it's really cool. You know, you've got the flexibility that most people don't have. We are improving this antenna, or this connector, this DART, digital analog radio termination. There's 16 digital lines, so it's digital, 4 analog lines, and it's a radio termination connector. So anyway, .11ax with its 8x8 is going to need more than 4 antennas. We've got that covered with an enhanced DART connector that's coming out as well. We're also taking the antennas that we normally use, like our 6 dBi patch antenna, 2566, and putting one of the DART connectors on it, so you no longer have to do this, you know, 500 times when you're doing a building. Also, it'll be a smart antenna. We're starting to put technology in so it can recognize the antenna and say, oh, you're 6 dBi, or maybe you're 30 dBi and it's not permitted. Well, maybe I can turn my power down and work with that if I know what it was, right? So that's a cool thing. But again, you can break it up. You can make it omnidirectional, any way you want. You just have all this capability. And if you're like a military company and you want 2.4 out the radio, if I said I want only 2.4 out that DART connector, I want it out because I want to up-convert it to a different frequency, use it for military, something else. You can do things like that with this that you can do with nobody else's AP. So we got a rich history of these modules and silicon that we do with things, right? So if you look at like what we did with spectrum analysis, hyperlocation, now there's RF ASIC. RF ASIC is that little red radio I was telling you down here in the bottom. Unlike a Wi-Fi 6 AP, that's Cisco, that's us, that's Richfield, Ohio, okay, and the engineers in San Jose. What this does is not only is it a full spectrum analyzer, but it's a software definable radio. It's got a lot of things in there. So there's 2 connectors on that. Out of the gate, this thing uses one of the connectors on its own antenna. It can pull itself away. When you make a Wi-Fi 6 AP, a lot of people get wrapped around the axle with whose chipset are you using? Is it Broadcom, Marvell, Qualcomm? Well, as you use a different vendor's chipset, each vendor has the ability to do their own DFS. Some people do DFS better than others, right? If I have an RF ASIC and sit there and it has a full spectrum analyzer in it, I can go over here and go, hey, what was that? Was that really a DFS event, or was that a bad malware client? You got a client that's making noise it looks like a radar signal. If you have a Wi-Fi chipset, you might see that as a radar signal and have to go off. We AND gate that thing. We look into it and basically take that thing. There's just a block diagram of what this does. Takes all the baseband IQ stuff, puts it to a spec analyzer, puts it to a Sage DSP. We process on it, do baseband processing, and then we send it to the AP. There's 2 of them. The first one does the monitoring. Second one is AOA, angle of arrival. You may see an AP later that uses that same radio for part of the hyperlocation. But if you look at it, you can do full spectrum analysis, see what's on there with a 9120. So you got a clean thing, but I was harping on this DFS stuff, right? So if you think about it, if I take somebody else's chip and it has a false DFS, and I've got a full spectrum analyzer and I AND gate that, and you're a client and you're making noise and you're tricking my Wi-Fi chipset to think it's a false, our analyzer goes, no, I'm gonna override that and tell you to stay on that frequency. You're just fine, and you can continue to operate. Well, that's an improvement on performance. If you're in Europe and it's 600 seconds or however long it is when you have a DFS event, having a separate radio that can do that kind of stuff is really cool, because it's not the radio servicing the clients. It's out there and can do something different. But it can also do things like fast locate. If you've got these APs on the ceiling and you got a client and I want to find it quickly, if I have to use a serving radio, then I've got to use the serving radio and time slice it to find the client. If I've got a dedicated radio, an RF ASIC radio like this, I can tell it, you look for the clients, find them, and quickly link them. So APs that are sitting there with 9120s can fast locate. They can do DFS. That's the stuff it's capable of pretty much now with software. However, this is what I think is kind of cool. You can't write software to do amazing things unless you have hardware that is capable of amazing things, right? So I'm going to tell you what this is capable of doing, not what I've got software today for. So you can kind of like, yeah, I'll believe that when I see it if you like. But every radio signal on the air has a fingerprint. If you shut your eyes and a woman's talking over here and a guy's talking over here, you pretty much figure that out on your own. It takes you a little while for you to understand that's Fred's voice as opposed to his voice or your voice, right? And you could put buzzwords on it, machine learning, if you could do that, right? But what happens is when the radio signal goes on the air, every radio transmitter on the planet Earth makes a unique signal like a fingerprint, right? Its oscillator takes a little while to start. This happens, that happens. At many layers, I can look at that and go, that's not the same. So if you're not the same iPhone as his iPhone, and I know that before we're even talking about MAC address or where you're at or what you're doing, that's pretty cool, because that's kind of like Cisco likes to brag about encrypted traffic analysis. Now, I'm not a security guy, but they say that I can find malware in a packet that I can't even decode. Well, I'm doing this on the RF side of things. If I could tell that that's your iPhone and not his, you're not going to spoof him. And on future products with hyperlocation, now I'm not going to tell that, I can tell where you're coming from too, right? So that's what's kind of cool about this. It's kind of like, you can, my buddy Jim Florwick made this slide up, and he's like, gosh, it's kind of like, biometrics for Wi-Fi. It's like, yeah, that's some of the stuff that's sort of coming, right? And I don't know what I'm doing time-wise, but I'm done with this slide. Why don't we talk about what you guys want to talk about?
Were you able to maintain the X and Y for mounting of the EP?
Yes, the exact same mounting brackets for everything we have works with these products.
I don't know if you understand how valuable that is.
I do.
That's such an incredible feat.
Yeah, the only time that we have not done that is we've made some littler, physically littler APs, and at that point we have a different bracket for it. But that was a big fight. We want to keep the same brackets. People have got a lot of work invested in that kind of stuff. You can't just start pulling. It's kind of funny. We did get rid of one bracket, so I might as well talk about brackets. Bracket 1, bracket 2. Okay, bracket 1's designed for ceiling. Bracket 2 will mount on an electrical box, a wall, anything you want. Bracket 3 is for an in-tile bracket. You can just put it in the tile and the AP mounts flush. A lot of hospitals, people use that. I really like that. But we kind of deprecated that bracket because Cisco's a big ship. You put your hand in there and she don't always turn, right? And for us to make another bracket, get it out, add it to, we decided to let partners like Exceltex, Oberon, other folks kick out these kinds of brackets and things. So we don't make an in-tile bracket anymore. That you have to get that through a third party. But I'm telling you a quick story, just to tell you this. There was a hospital in the UK had a fire recently. The AP was in one of those in-tile brackets, right? And of course there was no suspension behind it, right? The air conditioning unit went on fire, the whole thing went, and the AP is hanging from its Ethernet cable. All the plastic is melted off of it. You're looking at the metal and there's a green light and there's some idiot connected to it. And the point is that damn thing worked, right? And that's why I sometimes pour water on APs, throw them around, all that, because I pretty much know that we build it good. When we stop building it good, I'm going to go drown night crawlers and I'm done talking to you guys and they can do what they want. But as long as I got anything in it, I want it to be a quality product.
What was the difference with the 9117 that made it only compatible, not certifiable?
What the big difference there was when 8x8 came out early, they didn't think that you needed the OFDMA and the uplink, okay, because hell, you got 8 radios can hear one client. There's all these benefits to 8x8 that they were touting. So the chipset was limited. There's that same chipset vendor, if you will, has got another one in the pipe where that does work in the uplink and downlink. So we're not done making APs, right? Remember I told you we kicked out 2 early ones, that are standards-based. The one that's standards-based that doesn't do the up and downlink is 8x8, right? And well, why did you kick it out? Why didn't you just put it away? Because others have it right now. And if you've got an 8x8 and I don't, then if I'm your sales guy, I'm like, hell, I don't even know how to make one yet. They ain't got it out the door yet. If you're going to win RFPs, if you're going to sell product, if you're at college and you want to tout, I got the very best Wi-Fi on the planet Earth, the very latest one, 8x8, we got that for you. But the downside is that one little uplink. And people argue it's like when you're on a plane, the pilot goes, you're going over the mountain. It's like, don't tell me that's crap, just get me where I want to go. Well, the 8x8 will get you where you want to go right now. But it won't get you on paper Wi-Fi certified.
About your fingerprinting.
Yes.
The fingerprinting. So that a lot of questions. What is your take about privacy? I know, so you can tell this is his phone, this is my phone. So the ISP already knows that. Right. But now you're putting that power into the hand of any customer who's willing to go with the Cisco equipment.
Right.
So what is your take on, is it,
well,
you can do it, but
it's a vexing problem. What's your take if I take your picture and go place it on my website right now? Or if an image, if I could take a picture of a child and find it online, know where that kid lives, heck no, you don't want that stuff, right? But did the surgeon wash his hands before he did surgery? Well, I might be able to tell you if he went to the sink. You got to figure out whether that's what you want. You don't have to enable something because it's there, I mean, if I got a gun that's got 18 bullets, I don't have to load all 18 to probably take care of the problem I've got right now. I don't have the answer for you on that other than to tell you that I'd rather give you the ability than have somebody else give it to you and me go, I might do it, so that's why.
Okay, fair enough.